Today we're going to be looking at the 6 trig functions in right triangles. Now the main thing when it comes to this is we have the original 3, sine, cos, and tan. However, we also have cosecant, secant, and cotangent. These 3 are the more common ones. However, once we get more advanced, we end up using these 3 trig functions as well. In total, there are 6 trig functions. When it comes to identifying these functions and writing the trig ratios, we're going to have 3 main steps. Step number 1 is going to be to label the h, the o, and the a. So that's what we want to be able to do first. Can we label the hypotenuse, the opposite, and the adjacent using the reference angle or the provided angle? Step number 2 is going to be to identify the trig ratio. Once we know which trig ratio we're using out of the 6, then we will be able to write our trig ratio. And then step number 3 is just going to be to substitute our values for h, o, and a. These are the 3 main steps. The problems will not be difficult at all, which is kind of nice. So I'll review first of the easier problems here. If we have sine, great. That's step 2, but let's go to step 1. Step 1 is to identify h, o, and a. Our h here, the hypotenuse, is going to be the 25. It is the corresponding angle to the 90-degree angle here. Our angle is here, therefore our opposite angle is 20, and adjacent is going to be the 15. Step 2 is to identify our function. Our function uses sine. And sine on our little paper here tells us to use O over H, the opposite over the hypotenuse. O over H. Step 3 just says to substitute. So we have 20 over 25. And then we're done. We are not going to be simplifying the expressions. We're just going to write the trig ratio that is desired. Let's go to tan over here on the right side. Step number 1, label H, O, and A. H, hypotenuse. Opposite our theta here, 15. Adjacent, next to our angle of reference. Step 2, identify our trig ratio, which is tan. Tan tells us to use O over A, opposite over adjacent. O over A. Our O is 15. Our A is 3 square root of 11, or radical 11. We could simplify 15 divided by 3, but we are not simplifying or reducing our fraction here. We're going to leave it the way it is. Let's move on to number 5 here, which is secant. Let's go to H, hypotenuse, opposite, adjacent. Secant here, it tells us to use the hypotenuse over the adjacent. H over A. Therefore, this is going to be 25 over 20. And then we're done. Secant is the opposite of cosine. Cosine uses AH. Secant uses HA. It's just flipped upside down. If we look at cotangent here, for number 6, our H, our opposite is the 6. 4 is our adjacent. Cotant is the opposite of the tan. So instead of O over A, we're going to end up using A over O. A is 4. O is 6. Let's go to cosecant here. We haven't done one of those examples yet. This is going to be the opposite of the sine here, flipped upside down, OH, HO. So cosecant here, hypotenuse, opposite, adjacent. This one's going to be hypotenuse over opposite. 7 square root of 2 over 7. I can already tell the 7s are going to be reduced or simplified here. Just give me a radical 2, but we're not doing that. Let's go cotangent. Let's just practice these just to see the pattern. We just do 3 steps. We label H, O, and A. Identify cotangent, A over O. And then step 3, substitute, 5 over 12. When we're writing the trig ratios of the 6 trig functions, it is not difficult. We are just writing a fraction and in this case, a number over a number, or a side of the right triangle over another side of a right triangle. We're just writing expressions, and that's it. Hope this video was helpful. Leave a like. See you all around.